Hello everyone. Today's topic is called Become a More Effective Butterfly. It sounds like a metaphor, and it is, but not a motivational one. It's a methodology framework. We all know the butterfly effect says, a tiny initial perturbation, amplified non-linearly through a system, can produce results far beyond expectations. Today I want to borrow this framework to answer a very specific question. Now that Claude Code can autonomously execute, debug, and search, where should you, as the user, focus your limited attention? The answer isn't use it harder. It's input more precisely. Today we'll look at 4 Claude Code features: Plan Mode, Git Worktree, Subagents, and Claude.md. Each one is about flapping your wings at exactly the right node, then letting the system generate the storm on its own. In these 15 minutes, we won't talk concepts. We'll talk usage, where to flap, and how to flap. Lorenz's discovery wasn't really about weather being unpredictable. It was about something much more profound. Tiny initial differences repeatedly amplified inside the system outcomes far out of proportion. He rounded 0.506127 to 0.506, just 0.000127 less, and the entire weather prediction became unrecognizable. There are 4 layers of meaning here, each directly mapping to today's methodology. First, the system is nonlinear. Tiny inputs don't add up linearly. They get repeatedly amplified by the system's internal mechanisms. AI is exactly this kind of system. Second, the quality of initial conditions matters more than quantity. How many times you flap your wings isn't the key. Where you flap and in which direction is what matters. Third, determinism doesn't equal predictability. You can't calculate in advance which path AI will take, but you can precisely set the starting point so it unfolds in the right direction. Fourth, linear causation is an illusion. The harder I push, the bigger the result. This logic fails in complex systems. Remember these 4 points. Every feature we discuss today is designed around one thing: making your tiny input land precisely on the system's most sensitive node. Let me start with a question. What is your role in a traditional workflow? The answer is usually the energy source. You put in effort, the system amplifies it, and the result scales proportionally to your input. This is the linear model. But AI has changed this equation. AI is not a faster tool. It's a nonlinear amplification system. One good initial condition can unfold inside AI into dozens of execution steps, far beyond what you could accomplish manually. So the human role has fundamentally shifted. Traditional model, effort equals outcome size. AI era, quality of initial conditions equals direction and scale of outcomes. This means something counterintuitive. 1 minute spent thinking the problem through is worth far more than 1 hour of hands-on execution. Because 1 minute of precise input gets amplified by AI into an hour of high-quality output. This is the new interpretation of the butterfly effect. You are no longer the butterfly struggling to fly. You are the one who decides where the butterfly flaps its wings. Before we discuss solutions, let's look at these 3 pain points. Their essence is the same thing. Your precious initial input is flowing to the wrong places. Pain point 1, manually chaining workflows. Each step relies on you manually bridging the gap. In essence, your attention is serving as a connector rather than a steering wheel. This is a waste of tiny input. Your judgment isn't being used on what to do, but on how to pass it to the next step. Pain point 2, manually transferring knowledge. Every new conversation, Claude knows nothing about you. You re-explain background, conventions, past mistakes. This is repeated consumption of initial conditions. You're resetting the starting point every time. The system never accumulates. Pain point 3, long tasks lost midway. The more complex the task, the more likely context blows up or one blockage stalls everything. This is the amplification chain breaking. You set a good initial input, but the chain broke during amplification. The solutions map to these 3 symptoms, not about flapping harder, but about removing the friction that wastes your wing power. The most critical point in the butterfly effect, the direction of initial conditions determines where the storm ultimately lands. This is the problem Plan Mode solves. Claude is eager. You say add a feature, and it immediately starts writing code. But if the direction is ambiguous and it writes 200 lines down the wrong path, that's a textbook case of a tiny ambiguous input being amplified into a massive mistake. Plan mode forces Claude to read code first, understand dependencies, and not modify a single file until you approve. This think before doing mechanism lets you confirm the initial direction is correct before releasing AI's energy. Extended thinking is the complementary deep tool. When enabled, Claude allocates more reasoning resources for deeper self-argumentation before responding. For architecture decisions or complex bugs, this means the AI's initial output direction is itself higher quality. Combined, they form the first half of this equation. Precise initial direction AI unfolds dozens of execution steps high-quality results. Get the direction right first, then flap your wings, and the storm will unfold on its own. Let's see how this feature turns set direction first into actionable steps. This is the first step of tiny input amplification. Before you say start executing, use plan mode to force AI to lay out its execution plan in front of you. 3 ways to enter. At launch, Claude, permission mode plan. During session, Shift plus Tab times 2, cycles through normal/plan/auto accept. Set default. In .claude/settings.json, set default mode, plan. Extended thinking toggle, Option plus T, Mac/Alt plus T, Windows. Key point of the demo scenario. Input, migrate the user auth module from JWT to session. Help me plan it. Claude starts scanning code, finds 12 related files, 3 potential conflicts, generates plan.md, then stops and waits for your approval. This is the critical pause point in the tiny input massive outcome chain. With one small confirmation action, you determine the direction of hundreds of lines of code to follow. After approval, AI will execute. But now you know where it's going. A butterfly can only flap once. But what if you could flap 3 times simultaneously? Git Worktree answers this question. When you're unsure which approach is best, don't guess serially. Use 3 tiny launch inputs to simultaneously trigger 3 independent butterfly effects. 1 line command times 3 parallel Claude sessions equals 3 complete solutions ready for you to pick. Each session runs in an independent branch and directory. No interference, no context contamination. This is geometric amplification of tiny input. Your total input cost only triples, but the exploration space expands exponentially. You simultaneously cover 3 different initial conditions, letting 3 nonlinear systems unfold in parallel. In the end, you only need to do one thing. Pick the best result and merge it into the main branch. This is also a new perspective on the butterfly effect. You don't have to guess which butterfly will cause the biggest storm. Let them all fly at once, then observe which weather pattern turns out best. Note: parallel sessions consume tokens quickly, best used for critical decisions worth deep comparison. This demo shows 1 person, same time, letting 3 AI systems unfold in parallel. Scenario: you need to add a caching layer but aren't sure whether Redis, in-memory cache, or database query optimization fits best. Traditional approach: pick one, write it, if unsatisfied tear it down, and start over, serial time and energy drain. Worktree approach: 3 commands, 3 tiny inputs, triggering 3 independent amplification chains. Claude W solution: a Redis approach unfolds in its own branch. Claude W solution: B in-memory cache approach runs in parallel. Claude W solution: C query optimization approach executes simultaneously. 3 sessions, no interference, 3 complete implementations done in parallel. Your total input: 3 launch commands plus 3 task descriptions. What you get back: 3 complete, comparable solutions. This is a concrete demonstration of geometric amplification of tiny input. In the end, you only need one action. Git merge the best solution, Git Worktree prune to clean up the rest. Subagents are the most direct embodiment of one input triggers multi-level cascading in the butterfly effect. One delegation instruction, tiny input, subagent autonomously executes dozens of steps, reports only the conclusion back to you. Massive result. There are 2 layers of value here. First layer, preventing context contamination by noise. The subagent's exploration process, how many files it scanned, how many dead ends it hit, all happens in an independent context window, never flowing into your main conversation. Your main thread context stays clean, retaining only key decision-making information. Second layer, protecting your attention, your most precious initial input. Your attention is finite. If you scatter it across scanning the code base, reading docs, researching approaches, execution-level work, you won't have enough bandwidth for what truly needs your judgment. The design philosophy of subagents is, let AI do the amplification work. Let humans focus on setting initial conditions. 1. Investigate this for me. Input can replace 2 hours of manual exploration. This is the clearest case of tiny input producing massive results. The best thing about subagents: no configuration needed, one sentence triggers them. This is the purest form of tiny input. You just need to clearly state what to investigate and don't touch the code, and the system handles everything else. Left side, basic usage. Use a subagent to investigate all API authentication implementations in the project, summarize findings, don't modify any code. This one-sentence Claude spawns a subagent. Subagent scans 47 files. Main thread receives a clean investigation summary. Your main thread context barely grew, but you got investigation results that would take hours manually. Right side, parallel usage. Use 2 parallel subagents to research WebSocket and SSE implementation approaches. List pros and cons for each. Don't write code. 2 instructions, 2 parallel investigations, 2 reports. Merged, you make the final decision. This is the core value of subagents. It amplifies your single tiny input into parallel multipath exploration. Your attention only needs to appear at the final moment of judgment. In the butterfly effect framework, there's a special kind of tiny input. It doesn't just trigger one-time amplification, but permanently changes the system's initial conditions. Claude.md is that input. You spend 30 minutes writing it, and you've essentially crystallized all your project judgment, architectural understanding, technical preferences, workflow standards, into the starting point of every conversation. From then on, every new Claude Code session starts from this initial condition. Those 30 minutes you wrote get amplified into every single conversation across the project's entire lifecycle. Expressed as an equation: 30 minutes of one-time input, continuous consistency amplification across the project lifecycle. This is the highest ROI tiny input. Compare, without Claude.md, you re-explain background every conversation. That's resetting initial conditions every time. The system never accumulates. Your energy all flows toward repetition, not progress. Define once, effective forever. This is how you make the system truly remember the power of your wing flap. This is the concrete form of the highest ROI tiny input in the entire talk. Let's break down what each line of this template does. #project overview. Write once, read every time. Claude reads this on every startup. You never need to explain what this project is again. #technical preferences. Write your judgment into system defaults. No any allowed, no inline styles. These are constraints you'd repeat every conversation. Write them in Claude.md and they become initial conditions for the system. No need to remind every time. #architecture conventions. Solidify spatial boundaries. Database operations only in /lib/db/. If this rule relies on conversation to enforce, sooner or later you'll forget to mention it, and AI will cross the line. Write it in the file, and it's permanently enforced. #workflow. Turn process requirements into automatic behavior. Must run pnpm test and in pnpm lint after every change. Once written, Claude automatically executes after every modification. You don't need to remind. Looking at the whole file, every line does the same thing. Transform your one-time judgment input into the system's permanent initial conditions. This is the most leveraged wing flap in the butterfly effect, not flapping anew each time, but permanently encoding how to flap into the system. Let's review the 4 features we covered today. Each one follows the same logic. Precise tiny input times AI nonlinear amplification equals results far exceeding investment. 0-1 aim right. Plan mode plus extended thinking. Direction is the most critical initial input. Get the direction right first, then release energy. 0-2 Widen the reach. Git Worktree parallel versions. 3 tiny launch commands simultaneously trigger 3 independent amplification chains, making uncertainty work for you. 0-3 Deepen the impact. Subagents keep the main thread clean. 1 delegation input buys back dozens of autonomous execution steps. Protect your attention for the real judgments. 0-4 Lasting imprint. Claude.md persist initial conditions. 1 input permanently changes the system's starting point. The highest ROI tiny investment. Together, these 4 features give one consistent answer. In the AI era, human value lies not in how much effort you exert, but in placing your tiny attention precisely on the system's most sensitive nodes. The rest? Leave it to the storm.